Okay, so you're using your awareness of triangles and how they behave when constructed on the parts of a circle to make decisions about how circles behave. So let's take a look at 10-28, which is where we left off. We have a circle with a quadrilateral, A, B, C, D. Where we're told nothing particular about the sides. We don't know if anything's parallel or anything's congruent. So it is a non-specific quadrilateral. I'd like to move the points around just so they look a little bit more like the image in the text. B is a little higher. C maybe is a little lower. It looks something like that. We have a label down here at angle A that says X. And we know that the angle at C is 100 degrees. And we're asked in 10-28A to solve for X. So what are the things we know about this quadrilateral? Well, we don't know if consecutive angles are supplementary. As a matter of fact, if we conclude that these are not parallel lines, we can say for certain that they're not supplementary. So we're going to have to go about this another way. So I see an inscribed angle here at BCD. Let's see what we can work with there. I'd like to be able to make an arc. So how about if we have a midpoint or center of this circle? Will that allow me to make an arc? Center and 2 points. Center and 2 points. Okay. So this is kind of interesting. Let's create an angle here at B, E, D. But let's do it with segments. This inscribed angle here that's given at 100 degrees. What do we know about its relationship to this angle, major angle BED? I don't want to label because my drawing is not to scale. This inscribed angle is inscribed in this major arc, BAD. Let's add some color to this major arc. Ooh, I guess I can't color just the arc, although I do kind of want to. So let's just see if we can just decorate just the arc. Can we do that? I got the whole circle. So choosing just G, we now have a designation for major arc BAD. Now remember what we learned today when the angle itself is 180 degrees, that angle BCD would be 90. Well, it is still true that angle BCD is half of the intercepted arc. So let's go backwards. If we know BCD is 100, this intercepted arc must be 200. This arc measure, this central angle and arc measure, this central angle and arc measure must have, I'll say an arc must measure 200 degrees. So think about that. And see if that makes sense. This central angle must be 200 degrees because this angle is half the central angle. The central angle has a relationship to arc BAD in that their measures are considered the same. So the measure of arc BAD is 200. So let's edit this to add the clear vocabulary. The measure of arc BAD is 200 degrees. Now that's not the length, that's just the measure in degrees. They have told us, they have also asked us to find the measure of arc BCD. So that's BCD, BCD, BCD. Well, if measure of arc BAD, the black dotted line, has measure of 200 and there's 360 degrees on a circle or on a complete arc, then 360 minus 200, the measure of arc BCD equals 160 degrees, and that is going to help us find x. Arc BCD is 160 degrees. That makes angle DEB what's it called? DEB. You must have measure what degree? If the measure of arc BCD is 160, then the measure of the central angle is 160. That will help us find x. Okay. Oh, I missed a letter in DE. I'll fix that. If the measure of angle DEB, this one right here at E, has a measure of 160 degrees, then x has what relationship? The inscribed angle is exactly half of the central angle, so x must be 80. Degrees. So that's great news. Let's see what Alejandra says in 10-28b. She says, I think that the opposite angles of a quadrilateral that is inscribed in a circle must always be supplementary. So think about that. Why might that be true? If opposite angles, and let's fix this quadrilateral again. Looks something like this. If angles that are opposite in a quadrilateral that happens to be inscribed in a circle, each intercept a portion of the circle. So BCD intercepts at B and D, and BAD also intercepts at B and D, and those two intercepted arcs add up to 360, then the two opposite angles that are related to those intercepted arcs have to add up to 180. So here's our conclusion. Let's clean this file up. Let's turn off the axes. Let's move some stuff around. I'd like you to add this to your notes. If a quadrilateral is inscribed in a circle, and I'll fix that typo, the opposite angles face arcs that together form the entire circle. Since the measure of each inscribed angle is half the measure of the arc that it intercepts, the sum of the angle measures must be half the sum of the arcs, or half of 360, then the measures of the opposite angles must add up to 180, therefore are supplementary. Now remember, this isn't true for just any quadrilateral, but it will be true for quadrilaterals that are inscribed in a circle. If I were you, I would practice 10-29 as well. We've got time to get you through A. So let's see if we can analyze the arcs here. Well, we're looking at something similar to the similar triangles problem we did in class today. So let's go ahead and draw those. Add those chords. And let's see if we can figure out what we have here. And here. Can we find a relationship between the intercepted arc for and here and the intercepted arc for here? Yeah, they are the same arc. So that tells us that this angle right here is the same as this angle right here. And I'm going backwards. I need to go put that back in. Right here. Same as here. So I've got an angle-angle similarity situation, right? Because I've got vertical angles here. I don't have a point, do I? So I've got a pair of vertical angles and one other pair of angles that intercept the same arc. Can I highlight the arc? Arc through these 2 points, arc through these 2 points. So I can set up similar triangles where 3 is to 2 as x is to this segment here. You're given some information about this chord. You have to do a little subtraction to find this segment.